Myself, Jobin. I work for Percona, and my life was with databases throughout all these years. And started PostgreSQL in late 90s. So all these years, there were a lot of learning. I am still learning SQL. So I just want to share some learnings with you, and what is the advantage of investing your time in learning SQL. And one important thing which I want to mention is SQL as a language is not stagnant. It is continuously improving version after year. Now, if I look back, there were many releases, SQL standard releases. But unfortunately, when I review many of our customer environments or user environments, I still see people writing SQL 92. So starting with the select column from some joins. So because they are not aware that I think there were many improvements came into the SQL. And they can leverage all those features to improve the performance, concurrency, and take advantage of all the benefits of modern SQL. Say, when you are using Postgres new versions like 17 and all, there is a lot of new features in terms of SQL. Somehow, when a Postgres version is getting released, everyone talks about the DBA features, say how to set up replication or all other sorts of things. That gets attention. The SQL features gets buried deep somewhere in the release notes, and which is not getting sufficient attention. So this is my effort to invoke your curiosity and encourage you to put your effort in spending time on learning SQL. So I give a quick introduction about why to invest time. To get you started, to understand all the benefits. So let me take you through some performance data. Many of times recently, when I look at the real user data, how their database is performing, I see this kind of information, like majority of the time, the database is spending on network traffic or all sort of extra work, which is not yielding any benefit in terms of SQL the query performance. And we can see that in this case, vast majority of the time is spent on network or delay. This is the time your session is not on CPU. It is out. So you know how operating system does the context switches, right? Say if there are 10 runnable processes in the system, and if you have only 2 or 3 CPUs, majority of the process won't be running. And there are other reasons why the SQL won't be really running. One major problem is the network. And I think some of you attended today's morning session with Mehboob Alam. And one important point he stressed is how network is affecting the performance these days. And the technology is evolving. This is year 2025. And now, if I look at the data center, the network is emerging as the biggest performance destroyer. Because CPU computing power is improved like anything. Now the modern Intel chips, one single socket is giving 288 CPU cores. And memory also speeded up a lot. But still, network is not speeding up. It is where your performance is getting hurt. And I am not seeing a improvement coming anytime soon also, because we are hitting on many of the limitations of physics. And when I look at some of the cloud vendors, the database or service, I even see a lot more weight happening on the client read. This is the time delay happens in the application server and the database server interaction, and the database is spending time within the transaction waiting for some next statement to come in. So a bigger chunk of the time is spent on this back and forth communication. This happens mainly because the developers don't thought about all these problems while writing or developing the code. And these are indications of chatty application. So the application server and the database server will be on continuous chat, sending some query to database server, getting the result, again sending some information. So back and forth communication is eating up all your database throughput. And how to measure the latency. So if you don't have any tool, you can just use ping. It sends an ICMP packet and it can show you the network latency. And one might ask, how to ping or use network latency if you have a database or service offering? And one easy method is to use PGBench. Use PGBench. Here, we can specify as many numbers, as many client connections are required, and send a select hello world. So basically, the select hello world will be sent to the database, and the database will process that statement and send that hello world back to the application. So the back and forth communication is ensured. And when we can fire it through as many clients as possible, the PGBench we can specify the number of clients, and then we can monitor what is the throughput we are getting, where is the latency. And this is one example. So here we can see that the network, the latency is 0.01 millisecond. One might think that, okay, that is negligible delay. But with that, I am getting a transaction per second, 60,000. But what will happen if there is a small increase in that network delay? So here is a case, 0.28 millisecond. The transaction per second drops to 35,000 from 60,000. And when it comes to the DBAS solutions, because a part of the database will be sitting in one corner of the data center and your application server will be sitting on the other center of the actual data center. So we may see a network latency of 0.48 milliseconds. Your TPS drops to 2,000. So think about that, from 60,000 to 2,000, just because of network latency. And this is the elephant in the room, but no one sees that. And the problem with the network is not something very secret about. This is, if you search in the net, there are so many papers published about this problem, because today's world is crippled with this issue. And people don't know how to solve it. This is from Stanford University, and this is from AWS, published in IEEE. So everyone is battling secretly on this problem, how to solve this. Because if this problem becomes worse and worse, all the investment done in database as service or distributed computing, microservices, all those things will come to a halt. There won't be any you won't see an actual benefit out of it. And summary, chatty application takes a lot of round trip back and forth, and chatty applications requires concurrency control a lot more, because you need to start a transaction, then send some statements one after another, and during that other sessions should not affect your statements. So strict concurrency control is required. And performance of network-bound workloads are questionable. It's becoming worse and worse. And other problems of poor SQL, so other than just chatty applications and things like that, plan instability. Very frequently, I get this kind of complaints. So the SQL was working till yesterday, suddenly something happened, and the plan drift happens because the way we conveyed the SQL statement to the database is confusing. So the optimizer can do it in a different ways. There will be a number of combinations. And a slight change in stats will change the plan to somewhere else. So the plan drift happens. And the wastage of resources. So this is another consequence. In many customer environments, I see this because they try to increase the concurrency by bombarding the database with so many sessions, so many SQL statements. And what happens is, because of the concurrency, many of the transactions will be aborted because primary key violation or some kind of constraint violations. So here we can see in a day, this is the average of a day, 95,000 transactions are rolled back, aborted and rolled back. And here is another example where the numbers are going to millions. So when we have this transaction block with the multiple statements, practically this is what's happening. Unless we monitor these things, we don't know the damage happening in the system. See, when we say a transaction is rolled back, there is already a lot of work done. So not just the statement processing, the DML processing. It already dirtied the pages in the memory, and it already generated the val records. So the work is more or less completely done. At the end, we are rolling back. So the work done is not getting reduced. All the effort is going waste. It's like before you are exiting the door of the airport, you are rolling back the plan. You already traveled all the way. And so the entire effort goes waste. And here is a beautiful blog post by AWS. So if anyone is downloading this PDF file, please, I highly recommend to understand all the wastages happening when a transaction rolls back. And so when people don't know how to write good SQL, they tend to write a lot more database functions and procedures, because the idea need to be put into more complex logic. So the problem with the stored functions and procedures, it adds a lot more overhead, because it is a separate execution engine. So in Postgres, you can write stored procedures or functions in other languages like Python, Perl. Today also there was some sessions about Rust. So you can write the functions in any language you want. But the point you need to remember is it is a separate execution engine, not Postgres, it's outside. It sends the SQL statement back to the Postgres and get executed within the Postgres and sends the result back to the execution engine. So it's a back and forth communication happening when you're writing a stored function or procedure. And there will be multiple statements, of course. There could be loops within the functions. And that is not atomic. So there could be the procedures, there could be race conditions. And if you want to look into the source code, there is a reference. And yeah, like I mentioned, when we have this kind of transaction block within begin transaction and multiple statements, we need to assume that there is another session which could be doing this. So the concurrency control is going to be more complex in this situation. Sometimes we may have to take lock, or sometimes we need to explicitly state the type of concurrency we want. And another problem is the limitations of Postgres It's not just Postgres, any database. So when you are firing a SQL statement to any database with many tables, the database engine has very limited time to figure out what is the best execution plan. So if you have, say, 10 tables joining together, the permutations and combinations will be, or if you consider all the indexes also, there will be n number of ways that a SQL statement can be executed. And the database engine don't have the time to explore all the possibilities and come up with the best execution plan. So Postgres has these parameters limits specified. So it is going to explore only these only limited possibilities. So for example, G key or threshold is 12. So if you exceed that, Postgres will use some rule-based optimization, which won't be the real optimized statement. And end of the day, SQLs will be written by human being. So human limitations are there. So human brain has limitation in comprehending a lengthy SQL statement. Sometimes I see SQL statements running into pages. And if you ask the developer, can you explain this SQL statement to me so that I can help you to optimize it? They say that, okay, this is written by somebody sometime back, and we just modified here and there. So this is a common, because it's almost impossible for a human being to comprehend if the number of lines exceeds 50 or some number close to that. And those SQL statements may contain even serious bugs as well, because no one can really understand what is happening. And another problem with the poor SQL is temp file generation. So some of the, I think today also somebody was showing a case, every day generating terabytes of temporary files. So why this is happening is, so they pull out all data from all the tables and join it, and at the last stage they are applying the filtering condition or sorting condition. So it's like taking a full backup of the database, taking it to memory and doing all the calculation, and finally throwing up most of the data. So all these will generate so much of I/O, wasting all the server resources. And the complaint will be database is too slow. Yes, so here is an even bigger number. So when we see too much of temp file generation, what we need to understand is there is something wrong join order is happening, or filter sort operation is happening at the last stage, which should have been happened on the earlier stages. So this is the reason why you should invest your time in learning modern SQL. So and it's a never-ending process. So I am also learning. Every day something new thing I come across. And this is a beautiful blog post by Frank. Frank is sitting here. So and I would again recommend reading this blog post, and not just for this SQL statement. This SQL statement, he's trying to explain a case where two people are trying to book 2 seats in a theater close by, so that the couples can sit together. And he explains the concurrency control as well in this case, so how Postgres beautifully handles that. So same thing works with the Yuga byte. So, and another take from this SQL is that, so generally when I talk to somebody about, okay, you should learn, you should try to improve on this SQL using the modern features like window functions. The perception is that this window function and all is for analytical queries. So that's what people has that perception. But not really. The window functions are really useful in transaction workload. This is a good example. And again, today we were discussing about this. If you don't want to invest too much of time in learning SQL, the simplest thing we can do is learn CTE properly, common table expressions. This is really wonderful. And this is somebody who learns CTE properly, they can transform most of the queries. I think in last month itself, I tuned so many queries just by using CTEs. SQL statements running into hours become minutes after, because we don't have to worry about all these complexities like join collapse limit or GQ threshold, because we are specifying the order clearly in CTE. So the CTE means with clause. Yeah, you may be knowing that. And Postgres documentation itself mentions about some of the benefits. It avoids a lot of needless repetition in the execution, and yeah, so it makes things so simple. And another advantage of CTE is that it is even capable of overcoming some of the limitations of window functions. So normally, window functions won't allow us to create a lock, say lock a row or something. But with the CTE in place, the same window function will allow us to lock the row which we want to update. So we can avoid some of the limitations using CTEs. This is some of the wonderful things ever came in SQL language. And filter clause. And I don't know whether I should call it as modern SQL, because this is part of SQL 2003. But I included it in the presentation because I rarely see this. And without this filter clause, the query need to scan this table multiple times, which I keep seeing. Say people will be doing with multiple unions to get the same result. We don't have to do that. There is something called filter. Scan the table once and apply the filter on the result. So the table scan happens only once. And lateral join. Anyone using lateral join here? Yes. Good. So lateral joins are just like a for each loop in SQL. SQL language itself, so otherwise, without this lateral join, you may end up in writing stored procedures. Say, many of the stored procedures like get a cursor and iterate through that cursor for each. We don't have to do that. In SQL itself, we can have lateral join. This is an example. In a table, say we have 1, 2, 3. And for each of these rows, if you want to execute something, we can write, say select star from the same table, join lateral, execute that function. So for the first row, the function will be executed one time. For the second row, the function will be executed 2 times. That's a for each loop implemented in Postgres. I mean SQL language. And SQL and concurrency. So this is just for explaining the concept. I took a hypothetical example. So a table with an integer primary key, which I want to generate continuously. So sequences, auto increment columns. So that's the idea. But we know that all business requirement cannot be satisfied by auto increment. Because there are cases where we don't want to have a gap in between, or we want to generate a ID other than integer values, say the flight PNR number or something, some sort of that. So which requires some kind of business logic behind, do some computation and generate the ID. And when I generally ask why someone should use the sequence or serial, they give answers like it is for performance. but it is not really gives any additional performance. Look at the actual numbers. If there is an index on the column, the column which is getting generated, and taking the max and increment by 1, or the next value of the sequence, actually gives pretty much same performance. There is no performance difference. It is not for performance. It is for some other reason. And other argument I hear is that max function. So normally indexes will be ordered in the ascending order. So when you take max, it will be backward scan. So the backward scans are considered as slow. But actually that's not slow, because we are not scanning it. We are looking at only the end of the. So if you just try it out in a system, we can see that there is no performance difference, whether it is min or max. So it is not for performance. So then what is the problem? So instead of generating the column using sequence, if you just take a max this way or with a CTE, the problem is conflicts and concurrency. If two sessions are running the statement concurrently, it may result in two people getting the same IDs. But there is advantages and disadvantages. So one is it's optimism. Okay, there won't be any conflict, but that will result in low concurrency. Every business requirement is not require a high concurrency. For example, employee ID generation. So you don't generate employee IDs from multiple sessions parallelly through 100 sessions. That's not how the business works. Employees joins maybe one after another. So there will be concurrency of only 1 or 2 sessions max. So we don't require an extreme concurrency in those cases. And the advantage side of using business logic implemented increment is it eliminates the limitations of sequences. So, logical replication, we have to take care of auto-increment columns. And now it is, the data migration become easy if you don't have a sequence. And we can use any type of data types. We can have our custom logic. But it is usable for less concurrency. And this is, I think we briefly mentioned about the transaction aborts and rollbacks are expensive. So this happens when we try to achieve high concurrency by sacrificing the sequence and all. So there will be more transaction rollbacks. So in turn, it will affect the database performance, and it will generate extra val. It floods the log files. So the negative effects are there. If you look for high concurrency, we should expect a lot more conflict. Now, we have an option in slightly more modern SQL. We can have lock temporary during this lock will be during the statement execution. It won't be forever. Within the statement, we can acquire a lock so that the max ID generation won't be happening concurrently. So if you look at the execution plan, you can see that the lock rows happens in that stage. So we attain slightly better concurrency by it's a temporary lock. But this is achievable by this improved SQL statement. And so ultimately we are slightly sacrificing the concurrency, but we are avoiding many of the rollbacks. Yeah, so this is a summary of those things. So momentarily lock, So we are not sacrificing too much. I done this test in my benchmark, so it's not big problem. And modern SQL even allows this also. In an insert statement, you can have on conflict do nothing. So what happens is, if at all there is a conflict, assume that mostly it goes without conflict, and if at all there is a conflict, don't try to insert. So this even avoids that problem of rollback. So, and look at the return ID. So if the insert is successful, then only the value will be returned. So you are giving a database a statement to execute, and we don't know the consequence, whether it will success or not. It will come after execution. If it is successful, it will return the ID. Otherwise, no. The statement is not successful. It's as good as aborted, but actually it's not aborted. So the application can retry that. And this on conflict is so versatile. It allows us to even update the data. So Postgres provides an excluded special keyword which can be used for updating. Say if somebody tried to insert a data, but there is already a record sitting there, but because of the key violation, it is not able to insert, but the data is different. So we can say, please update the data. And the conflict can be detected using a key constraint or a value, a set of values, say conflict using an ID. And during the update, so on conflict, we are saying that, okay, do update. There we can even further give more validations on what condition the update should be happening. So all these things are supported. So you don't have to write lengthy procedures or triggers, all those things. It's so versatile. Once you understand this, you'll start using this, and your code becomes so simple, straightforward, no errors. And Postgres 15 introduces the merge statement. I think I don't have to explain this because the last 2 years we are hearing this. This is so amazing stuff. The merge statement is like insert, update, delete, everything clubbed together. And it supports multiple when clauses, conditions, and it is evaluated in the order specified. So logically, like a programmer can think very logically. It's evaluated in the same order. For each row, match is checked and associated actions are performed. So it's very easy to debug the merge statement. Yeah, but it's complex, slightly complex in terms of execution. So always I would prefer to use the insert statement with the conflict check. For more complex logic, you can use merge statement. And here is an example. So we talked about the chatty application, right? So when we have a statement like this, what happens is we are packing the data and the logic as a capsule and sending to the database server. So there is no back and forth communication required. So what are the values to be inserted? If there is a conflict found, what is action to be performed? Everything as a single unit of communication. So the single piece goes to the database, and things works out there and comes back with the information what happened there. So no need to have this chatty nature. And the merge statement has a lot of usage, the data reconciliation, logical data synchronization, data movement to warehouse databases, reporting systems. And largely it replaces stored procedures and functions. And in one of the real customer environment, we proposed this as a solution for systems which occasionally gets connected. Say, the user was trying to implement logical replication between their one system and another one to ensure that the data is flowing from one side to other. But they had a challenge. The systems gets disconnected frequently. They were running something like a cruise ship. So the ship will come to shore. That's the only time, or once in a while it gets connected to satellite. That is, and frequent disconnections happen. So logical replication is not a real good solution. So this is a solution proposed. You can have a solution as a single statement. And the merge statement in Postgres 17, it's improved further. So now it supports even returning clause and the merge action also. So there is no confusion what happened in the server side. So you send the data and instructions as a capsule to the server and just inspect what happened there, whether it is insert or update. And this is another very good blog post. I highly recommend. In this blog post, all these statements were considered. A comparative study is conducted. It's a very lengthy blog post. That will give the readers an idea of say how to think about the concurrency and rollbacks, the bloat which it might create, whether a constraint check is required. So multiple aspects are considered in this blog post. So it's a great example of how to use modern SQL. And let us see some good simple examples. So as I mentioned, replicating from remote machine. This merge statement can have FDW in place. So the select statement which is having underline, that is actually a select statement which is going to be executed on a remote machine. And the entire piece will be executed on the remote machine, and the result will be fetched to the target machine, and it will be merged with the local table. So basically, this is the easiest way to replicate some data occasionally. And you might be wondering that column, last modified, I think at least some of you are familiar with, because this is something which most ETL systems uses. They call it as watermark method of replicating data from transaction system to DCS systems. So this can be executed without any ETL tool. You can just fire it through a FDW, and the data from the source and the target will be merged by a single statement. You don't say, sometimes people will be amazed. So we thought we need to write lengthy procedures or lengthy application to merge the data, but it's actually a single statement now. And another modern SQL feature is unnest, which I think it's not part of standard, I am not sure. But what it does is, it converts an array. So array is the smartest or most compressed way of storing data. Postgres supports array. And the unnest can turn this array into 90-degree and make it as a table rows. So this is really powerful. And it can support various data types. Yeah. And the tool which I maintain, I use it extensively. And here is a timescale DB blog post which explains this this unnest, usage of unnest is can be used to improve the performance by 2.13 times for data ingestion. So this is something which we discussed. Okay. And this is a slightly more complex example of using CTE, but this is something really happened in user environment. There were lengthy procedures, application logic to insert data into multiple tables. So this is an example of regular order and order details case. So the order is a kind of parent table, and order details is a child table which contains all the order information. And if you look at this, the order, the main header table need to have some information, and the child table need to have the additional information about the order. And if you look into this, there is an insert statement to the order header. And the select statement here is actually replacing the trigger which earlier was used for data validation. So now data validation and insertion into the header table is part of a single statement, and there is a returning clause. If the insert statement is successful, it will return the order ID, and that will be used for inserting into the child table. And we can have additional logic for generating the line numbers. And if all these things are successful, it can return the order ID. So basically, a very complex business logic can be placed as a single SQL statement. This actually done for replacing some of the, because they were encountering multiple issues like concurrency control. So they ended up in putting serial isolation level, but still the rollbacks were their headache. But finally they changed to this. And with the CTE, we can even control whether it can be materialized or not. In Postgres allows this. So if it is not materialized, it will be pushed down to the SQL statement, the SQL select part happening. And the data retention and archiving. So this is another common requirement. Every organization wants to implement the data retention policies. So we don't have to write really anything complex. So the data retention logic should be doing the old obsolete data. It should be removed from the table. And before removing, the data may require to be put into some another table as part of archiving. And make sure to delete only the data which is successfully archived. And do it in a single transaction. All these things will be the business requirement. And batch the operation. Don't do it as a bulk operation. Batch it. So with all these business requirements, one might think that this requires a big implementation. And in fact, one of my colleagues also was saying he never realized it is so simple in Postgres. It's a 2-line. So here what happens is delete from a table with some batching condition and returning the rows which are deleted and insert into another table. Just 2 lines. Without this, we will end up with all this criteria. We'll end up in writing complex logic in code. And really, this statement helped us in partitioning tables. Because this statement is basically taking some data and moving into another table. And that is what we want to do while doing a table partitioning. Using the partition criteria, if there is a conflicting set of records, we need to temporarily move it to somewhere else, partition the table, and put the data back. This is a 2-line code. And the advantage of when we put things as a single SQL statement, the biggest advantage is it become atomic. So you don't need to have a begin and commit all those things. It's become, by default, it is atomic. And everything in a statement is looking at the same snapshot. So you don't have to have isolation worries. And the effect of one statement is visible, not visible in substatements. So this is something we need to remember when you are using with clause or merge clause. And with the CTE, returning the data from a child, the earlier section is the only way to continue the changes. So if the remaining session need to see the data which is changed, so you really need to return. So these points which you may want to keep in mind. And like I mentioned in the beginning, so don't take it for granted. So we have tools and scripts which will allow you to understand where is the wastage happening, the wait events, study the wait events, and I won't be surprised if your system is still suffering with a lot of network-related latency. And address the problem where it is really hurting. So when we design for high concurrency or less locking, so there is a trade-off, right? So when we have high concurrency, we end up in more conflict. But when we have everything as a single statement, we can achieve that because it's atomic by nature. Yeah. So investing your time is what really required. I hear a lot of people working on studying prompt engineering, all those things. So invest some time in learning modern SQL. This may give you more value in real world. Your application concurrency and the total throughput, everything will come out of almost free. Only your investment time is required. Yeah. So here are some good references. Yeah. And if you are interested in the wait event study script which I mentioned in the first slides, so that is available in GitHub. You can just get it. Yeah, and please follow me in LinkedIn. Yeah, any questions? Thank you.